Hi there. Thanks for joining us. This is Space Nuts once again. My name is Andrew Dunkley. It's great to have your company. We have got a lot on this particular episode. We're going to talk about something that was said during the inauguration speech of one Donald Trump. We're going to listen to a meteorite striking somebody's front door in Canada, or close enough. And we're going to look at a couple of space launches, one that had a bit of a disassembly, and one of them that was successful, or there was a bit of an issue with sticking the landing on that one as well. Panspermia is in the news again, and if we can fit anything else in, we will. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Yes, indeed. And it is good to welcome again Jonty Horner, Professor of Astrophysics at the University of Southern Queensland, sitting in for Fred, who's gallivanting around the Northern Hemisphere somewhere up in the deep cold looking at stuff. Jonty, hello.
Hello, and I'm continuing to be the substitute Yorkshireman this week, so that's
yes.
It's good to be here.
It's great to have you. You're doing a fabulous job. And we're really, really pleased to have you. I wanted to start this week with the inauguration speech of one Donald Trump, who had select guests in his audience. They had to actually move it for the first time in 40 years because it was so bitterly cold. And so there was a limited audience. One might argue that.
A guy who was always talking about people being snowflakes out of interest.
Possible. And there's been a lot of reporting on some of the things that Donald Trump said in his opening speech, in his inauguration speech. And one of them was, we will pursue our manifest destiny to plant the stars and stripes on planet Mars. Now, this sort of follows on from his desire to increase US territory. Now, isn't there some kind of space treaty that bans us owning anything off planet?
There is. This is the space treaty back in 1967, and it's an interesting one of how the world has changed, because back then the only people really involved in doing anything in space were a few select nation states who were doing a lot of things as a way of proving that they were bigger and stronger than their rivals as much as anything else. But this was a UN declaration that the US is a signatory to, and one of the many things covered in the Space Act is the fact that there is no ownership of things off the Earth. The idea that things should be for everybody rather than for select states. And that's never really been challenged because we've never had the wherewithal to occupy and take over things in space. We can land there, we can drive stuff around, but it's like the moon. The US can land on the moon, but there's no way they can stop China landing or over on the moon. They can't claim things and protect them in any way. Now, there's two sides to this Donald Trump thing. On the one hand, fabulous that to some degree there's support there for space exploration going forward, and it does seem like it's been an ongoing tennis match for 60 years of one side saying we'll go to the moon, then 4 years later the other side saying, nah, we'll scrap going to the moon, we'll go to Mars, and back and forth. So it's really positive seeing some continued engagement with that side of space stuff. On the flip side, the language is a little concerning. Because, you get there, you put the flag in to say we got here, that's one thing. If you're putting the flag in as a point of ownership, then that's an entirely different thing. And it'll be very interesting to see what that sparks in terms of reaction from China, for example, who also have aspirations to go to Mars, and whether any of this is enforceable. Now, there's been a lot of discussion about the space treaty anyway in the context of the commercial use of space, because, like I said, when it was put together, very few nations were involved in space, and it was a nation thing, and now it's a commercial thing.
Yeah.
The great bulk of launches to space are no longer research missions launched by governments. They're commercial initiatives launched by companies. And that's a very different way of doing things, and legislation just hasn't kept up. There's a lot of discussions about the likes of Starlink and the proposed Amazon mega constellation and many, many others, and what the legality of that is, and should we be doing it all, and how do people have a right to control what is put in the sky above them? And none of that's really covered because the legislation hasn't kept up. So it's very much like the Wild West. And this is just yet another reflection of that in terms of it's all well and good having a treaty that is more than 60 years old that says you can't own things in space, we can't build a presence there. But the reality is if they go there and put the flag in and say this is ours now, and they have the wherewithal to defend that claim, which is another thing entirely, who's going to stop them?
Yeah, well, that's the $64,000 question, and his richest supporter wants to put a colony on Mars. So there's every chance that they've had a bit of a chat about this pre-inauguration speech too.
I remember many years ago, Elon the Great. What a wonderful character! I have opinions there, which I probably shouldn't dig into too much, but he said that he has this great aspiration that he should be the first person to die on Mars. And I think if you talk to a lot of astronomers, there's some interesting thoughts on whether that would be a good thing or not.
Yes, and yes, there were a few other things at the inauguration speech and the after party, if we can call it that, we're not going to go into involving Elon, but he got plenty of coverage on that in the news as well. But it's a really dicey one, and one wonders what will happen going forward. You mentioned China. They were invited to the inauguration. I think the vice president or the vice premier or whatever the title is for China did go. So maybe that's a good sign that relations between the two countries might be warming up a bit, but we'll have to wait and see. It's early days, but the next 4 years will be fascinating to say the least.
Interesting times, I think.
Yes, indeed. Let's move on to something as interesting but completely different. And this is where household technology has become such an amazing thing. I remember when I first got a camera at my front door at a house we used to live in, it actually recorded a lightning strike, which was amazing. Over in Canada the other day, a meteorite strike was recorded by a door cam. And they not only got vision of the thing hitting the porch, they got the audio, and it sounded something like this. That's quite a racket. I think I've got it again. There we go. That's fascinating, Jotty, isn't it?
Oh, it's just so awesome. I mean, one of the first things I thought about on this when I saw the photos and the footage was, hang on, this is Canada, which is notoriously cold and snowy, and all the footage is green and verdant. Turns out that this event actually happened in July last year, but we're only now getting to hear about it because there's been an official naming of this meteorite after the town that it landed in. So it's the Charlottetown meteorite now, and that's why this has finally come out as a story. So it's one of these interesting things with stories like this that you don't often hear about the news when it's new. You simply have to hear about it when something triggers that release. But it's absolutely fabulous. So there's actually a photograph I've got up on my other screen at the minute showing where this meteorite hit, and it's hit on the Redstone driveway, essentially, which is why you hear that smashing, shattering sound, because this was a chondritic-type meteorite, so it was quite fragile, friable. And so when it hit the ground, and it hit the ground traveling at what you'd describe as terminal velocity, so it wasn't coming in at kilometers a second at this point, it's coming in at a couple of 100 miles an hour, because the atmosphere had slowed it down, essentially. So it landed essentially like if you dropped a rock from an aircraft or dropped a rock from a couple 100 meters up. Hit the ground was harder and this thing shattered. So the noise you're hearing is the initial impact and then all the bits scattering around. This was a single impactor. And you see this beautiful spray distribution on the driveway on this photograph that looks very much like a ray crater on the moon. Very similar, but also very reminiscent of a similar impact that happened in the UK just a couple of years ago that was also a chondrite that hit somebody's driveway, and they did a really good job of collecting it. So it's really nice to see the similarities, and just looking at that debris and the scatter pattern, you can tell that this isn't an iron meteorite, that it was something quite light and fragile even before the bits got analyzed. The fact that on the video feed from this, doorbell camera, you see a freeze frame and you can actually see the rock as it's coming in. Because the frame rate was high enough that the frame before the impact happened, there's this black speck in front of the sky that is the rock just before impact. And that has to be unique. I don't think there's ever been any record like that of an impact as it happened. When it happened from close up, we saw Comet Schumacher-Levy 9 hit Jupiter, but even then the impacts were around the back of that planet. We've seen a few impacts on Jupiter's face since, but that's seeing an event at 600 million kilometers separation is very different to seeing a doorbell camera showing a rock 6 foot above the ground that is about to hit, that is a part of a celestial object. That's just awesome.
It is awesome. They collected some fragments, and that sort of prompted you to think about how this should or shouldn't be done.
Yeah, there's some really good and really bad examples of what to do if you think you found a meteorite. And this aside, 99.9% of the time when people think they've found a meteorite on the ground, they haven't. But a common thing people do is touch what they found to a magnet, because iron meteorites will be attracted to the magnet. This is really bad. So everybody I know who works in meteorite studies strongly says, please do not bring magnets anywhere near them, because one of the cool things about meteorites is they preserve the history of the early solar system. And one of the things locked in them is any evidence of weak magnetic fields back then. And if you bring a magnet next to it, you wipe all that history.
Oh, right. I like popping a hard drive.
Absolutely. Yeah. It's a little bit sad. The other thing I've seen that a couple of people have done that is really fabulous is if you get there very quickly when something's fallen, it's not going to be steaming hot, boiling hot like you see in the movies. It'll actually probably be clap cold and water will be condensing on it. But if you want to pick it up, one of the things about freshly fallen meteorites that's exciting is they are preserving evidence of another celestial body. And people are interested in things like possible precursor compounds to life. Could there have been life there, or proto-life, or things like that? Where does it have come from? Now, if you go and grab it with your sweaty human hand covered with oils and all the rest of it, you contaminate it. Now, I've got a couple of dogs. One of them's asleep here, and when we take them for their walk, they sometimes decide to do their business. And we've got very skilled at getting these little plastic bags and putting the bag over our hand and then picking the unmentionables up and putting the bag over it, so that there's no contact between human flesh and that which you wish to not touch in this case. And the same kind of thing would work for meteorites. So if you observe this happen on your Ring doorbell or other products that are available, see this happen, don't go pick it up with your hand. If you can, baggy it as if it's dog poo. Seriously. And then, if you can, store it in the freezer. So there's a fabulous story of a meteorite that fell in Canada again, that fell on a frozen lake in the middle of winter. It was recovered, and they actually managed to baggy it and store it in the freezer. And the people who did that, the scientists are thrilled with them, because it turned out that meteorite was incredibly rare, in that it is pretty much the only one we found with volatile material still in it. And if it had fallen somewhere where it was above freezing, that would have just melted and dribbled out of it. But what it thought is that may well have actually been more cometary material than asteroidal material. And all the things that we were able to learn from it were ensured by the fact that the people who found it, it was preserved because it fell somewhere really cold, so it stayed pristine. But then when it was collected, they bagged it up the right way, they put it in the freezer and they stored it. Now, a lot to remember, and the odds are nobody listening to this will ever have the good fortune of having a meteorite land on their driveway. But if you ever do, it's good to do the right thing, because that makes something that's already very valuable even more precious to scientists.
And yeah, that's good advice. And some more advice, if you do, practice what you preach and pick up the dog poo, don't put it in the freezer next to the sausages. Don't mix it up with the meteorite fragments, because, that could be very disastrous. But great story and quite amazing footage. If you haven't seen it, jump online and have a look for the, I think it was a Ring camera that they were using.
I think it was.
Okay, this is Space Nuts. Andrew Dunkley here with Jonty Horner. Let's take a little break from the show right now to tell you about our sponsor, Incogni. Now, when it comes to your online security, there are lots of options out there, plenty of things being offered to protect you from hackers and scammers and who knows what. But wouldn't it be better if you could cut them off completely before they find you? Instead of dealing with the problem after something happens, get ahead of it with our sponsor, Incogni. Now, this is an amazing piece of kit, as Fred would say, an amazing piece of software that takes all the hard work out of protecting you from any number of internet-related risks. Incogni will act on your behalf, deal with any issues or even objections, and get you off the radar. And you don't even have to think about it. All you have to consider is signing up with Incogni and let them do the rest. And it's not expensive. There are quite a number of options available depending on your needs. And right now, Space Nuts listeners can take advantage of an exclusive 60% off discount. Just log into our special URL and go from there. Incogni.com/spacenuts. That's Incogni, INCOGNI, incogni.com/spacenuts for a special 60% off deal. What happens after that is kind of like magic. Spam calls drop away, robocalls too, and your exposure to scams and cyber attacks will diminish significantly because you're so much less visible online. And don't forget their 30-day money-back guarantee if you're not happy. Go to the URL incogni.com/spacenuts and click on Get Incogni and see for yourself. Incogni.com/spacenuts, our sponsor. Now, back to the show.
3, 2, 1.
Space Nuts.
Next story, Jonty, involves SpaceX, and this was a test flight of their one of their mega rockets, the Starship, and well, things went well and not well. I think they got the big bit back with the chopsticks, but the other bit, well, it created quite a light show.
Absolutely. And this came very quickly to my attention when I got up that morning and looked on various platforms. And there's the most astonishingly beautiful footage taken over the Turk and Caicos Islands of what is clearly space junk. So it's coming in much too slowly to be a meteorite or something from beyond the Earth's immediate environment. They come in much, much quicker. You've got this beautiful shower of sparks moving slowly across the sky. I mean, slowly is a relative term. Slowly compared to when you've seen meteor showers and fireballs, fast compared to a helicopter or an aircraft. High up, but incredibly multicolored, incredibly bright, visible during the daytime. And it was very quickly made clear that this was the remnants of the upper stage of the Starship test launch. So they launched this rocket that is 123 meters tall, which just boggles my mind to begin with.
Yes.
After the first stage separated, the lower stage, which is the bigger bit, successfully came back and landed, which is an incredible achievement. They captured it, landed safely, ready to reuse again. But about 8.5 minutes into the flight, the upper stage encountered a problem and self-destructed. It's what SpaceX have coined a rapid unscheduled disassembly, which I think is kind of whimsical, but that's lovely. And it was exploded deliberately. When something goes wrong, you don't want it going out of control, so things are terminated. And then it fell back to Earth through the atmosphere and ablated, burned up, high in the sky, putting on a spectacular show. Now, a lot of people go, oh no, things have blown up, that's terrible. And SpaceX are fairly positive about it because I guess with spaceflight, the argument is you don't make an omelette without breaking eggs. The entire history of spaceflight is success built on failure. And when something fails, that's actually a real success in its own right, because it allows you to identify something that could go wrong and fix it so that it never goes wrong again. So this kind of thing has been a standard part of SpaceX's history, and their great success is that they accept these things and build on them. It did have some interesting kind of side effects. So I saw an interesting thread on Reddit from a pilot who'd been in the air when this happened, and they'd had to divert because obviously that strewn field where this is coming down has to become closed airspace. For, I think he said the rules and regulations were 30 minutes after it finishes in order to be just in case, just to be safe. Because the odds of one of these fragments hitting an aircraft are vanishingly small, but they're a lot higher than if there's not one of these events happening. So it's a safety thing. And it turns out that aircraft only have a relatively small margin of fuel error. So a couple of the planes involved had to declare what they call a fuel emergency, which is as bad as it sounds. I found this really fascinating reading through it because he was very detailed in it. A fuel emergency is not saying, oh my God, we're doomed. It's saying we're now onto our backup fuel, so you need to bump us up the landing schedule. So it's not panic. It's more give us a priority landing. But it's still really interesting that you don't necessarily connect immediately SpaceX doing a rocket launch and somebody on an aircraft having to divert or having to be delayed because the rocket launch went wrong. And at the minute, we have more rocket launches happening per week, per day than there has ever been before. And that's only going to get more and more common as the commercial space gets even more common. So this kind of stuff's an interesting insight into how all this stuff plays together, as well as putting on an incredibly spectacular light show. I mean, the footage is well worth going out and looking for it because it's so stunning.
It is. It's quite extraordinary. I had to laugh, though, because SpaceX has this habit of stating the bleedingly obvious. So Starship is a starship. Yep. And the upper stage that actually they had to destroy is called ship.
Yes.
Okay.
All right.
Well, I mean, that's what it is. It's a spaceship, so they just called it ship. Gosh. I guess it doesn't really matter what you call anything, but people will look back in the future at the history of these pioneering events and go, oh, they really didn't put much thought into that, did they?
I think they've actually done quite a good job about getting people on board and actually giving things whimsical names, things that stick in the mind. So my memory is, and feel free to correct me if I'm wrong here, but my memory is that the platforms that they bring the spacecraft back to are named after some of the ships from the culture novels by Ian M. Banks, which are fabulous, fabulous books. And that's a lovely little touch, because those names themselves are a little bit quirky and a little bit whimsical. And there's a fairly good history of giving things quirky names and also kind of almost anthropocizing things. We saw this with the Mars rovers when they got their own Twitter accounts back in the day, and people really got hooked into the human journey of this artificial lander on Mars. And I think companies are becoming aware of this and thinking it's a really good way of helping the public opinion and getting people more aware of what's going on. Mm-hmm. And these things stick a lot better in your head than a barcode.
Yeah, absolutely. I was just trying to look up some of the names of the SpaceX landing pads, but they are not jumping out in front of me. But I've heard some of them, and you're right. They are very, very, very unusual, some of them. While we're talking about the SpaceX disassembly, we can't really go past Blue Origin, which is probably going to become SpaceX's most direct competitor amongst others. And they've had success with, and here's another name, the launch of New Glenn.
Yes. This has been a long time coming. It was initially meant to launch in about 2020, but they've taken it careful, postponed, improved. Now, this was a smaller rocket. And when I say smaller, I think it was only about 90 meters tall. But this is looking like it's going to be the big rival in long-term future to SpaceX, certainly in terms of competing for American grants and NASA opportunities. Blue Origin have got interest, just like SpaceX, in being involved in the ongoing Artemis stuff, trying to get stuff to the moon. Yeah. And it's a really interesting mirror to the SpaceX launch, because with the SpaceX launch, the lower stage landed and was captured beautifully, but the upper stage detonated. With New Glenn, their primary focus was to just get the rocket to orbit. That was the goal. It's the first ever test flight. And that was achieved perfectly. They had a secondary goal, though, of trying to land their main booster back on their launch pad, and it didn't quite work. So SpaceX got the first part right. Blue Origin got the second part right. But it's a really nice bit of evidence that things are moving forward. And again, if we go back to when I was a teenager in the 90s, if you told me then that you'd have had reusable launch vehicles that are a commercial thing that were doing this, it'd blown me away. And now it's become commonplace. We have so many launches of satellites for commercial purposes going on that nobody ever hears about them unless they're really enthusiastic.
Or something happens that shouldn't.
Or something happens, yeah. It's that usual thing of nobody's interested in a news story saying that something happened and it went perfectly smoothly and it's perfectly mundane. But when something goes wrong, it's big news.
Yeah, it is. So in both cases, they had success and failure, and both parties basically said, no, look, this is good because we learn from these mistakes. And again, you're looking at names. I didn't look up what New Glenn stood for, where it came from, but it's an odd name for a spacecraft.
Yes, there's so many of these little things go around, but it sticks in the head. It's better than Rocket 1174B.
Yeah, True. I found some of the names SpaceX uses for its landing sites. These were the barges, I think, that they were using.
That's right.
Just read the instructions.
Yes.
Of course, I still love you, and a shortfall of gravitas.
They link back to these culture novels where I read them a long time ago, and you've got this hyper-advanced future society kind of thing, where almost anything is possible, and you've got these spaceships that are sentient AIs that are far more intelligent than anything else, but just kind of vaguely tolerate humans and all the other aliens as their passengers and have their own private inner lives and communications with each other.
Yeah.
They're quite heavy-going books at times, but that side of it's just lovely.
Yeah, it is. Yeah. Well, I'm on a big believer in quirky, so I don't really have a problem with it. But Ship, I think, was probably, that falls a bit short. Yes. But if you want to chase up those stories, you can read them on space.com. This is Space Nuts with Andrew Dunkley and Professor Jonty Horner.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
Now, Jonty, this is sort of a follow-on story to something that Fred and I discussed more than once in recent times, and that is looking at whether or not there might be life in the atmosphere of Venus. Yeah. And a new paper has been released that is actually suggesting that not only could there be life in the atmosphere of Venus, and they're not saying there is, could be, it may well have come from Earth.
Yeah.
That's interesting in itself. And they've backed it up with some data that they believe suggests it's a possibility.
It is. And this is all based on an idea called panspermia that when it was first proposed was firmly considered by the establishment at the time to be in the crank box, to be absolutely bonkers because it couldn't work. It's the idea that life can be transferred from one planet to another, carried on the back of meteorites. So you have a big impact on Earth, digs up a load of rock, flings some of that rock into space, and eventually some of those rocks land on another planet, and life spreads a bit like the common cold on a busy train. That whole thing of don't go near Earth, it's got humans, they're contagious. And when this first came out, everybody just thought it sounded bonkers because, firstly, life can't exist in space. Too hard, not going to happen. Then you've got, it would take millions of years on average for a bit to get from one place to another, and that's too long, so it couldn't happen. And finally, if a rock's ejected from a planet, then it's been in a big impact and that should sterilize it, so it should never happen. But then as time's gone on, all of those kind of conceits have fallen down a bit. We found meteorites on Earth from the moon. We found them from Mars. The Allen Hills meteorite's one of the famous ones, which led to claims of life on Mars a couple of decades ago that were eventually shot down. So we know that rocks get transferred from planet to planet fairly straightforwardly. When I worked at the Open University, this is from 2006 to 2009, there were people there who were working on this kind of stuff, looking into it. And what it turns out is that when you get a fairly large impact, up to the kind of dinosaur killing size impact, but the kind of thing that forms a substantial crater on Earth, the closer you are to the middle, the more intense the shockwave and the more damaging it is. And the further out you go, the less intense it gets. So the further away you are, the less strong the shock is. But that gradient is actually shallower the bigger the impact is. It falls off more slowly. What that leads to, bizarrely, is that there is a range of distances from the impact where that shockwave is strong enough to eject rocks from the surface of the Earth out of the atmosphere, particularly given that the thing that's just hit us has created a hole in the atmosphere to make it a bit easier, and that those rocks can be ejected intact, and the shocks involved in the rock are weaker than the amount of shock you'd need to sterilize it. In other words, bacteria could be ejected to space on the back of these rocks without being killed. So that's another thing in its favour. And then you get studies that have looked into the viability of bacteria in the vacuum of space with UV radiation that suggests that they can remain viable for a much longer period of time than you think, because when they go out into space, they kind of go into this stasis spore form, and UV damage kills some of them. I'm actually working with a PhD student down in Victoria who's looking at this, doing some experiments into the fact that the dead cells on the outside provide extra shielding. And that's even before you consider that there can be bacteria on the inside of the rock where the rock shields them. And they did tests. They put bacteria on the outside of the space station, left them a few months, brought them back inside, and they cultured them happily. All the steps seem to be that despite the fact this sounds a ridiculously outlandish idea, it's perfectly reasonable to think that life could be passed around the solar system like a tennis ball bouncing around at the Australian Open, going from planet to planet. So that's become an established possibility. It's led to a lot of discussions. There's interesting philosophical things. If we ever find life on Mars, and that's still an if, will it be life that has a separate origin to life on Earth, or will it be life that shares an origin with life on Earth? And that's not necessarily saying life started on Earth. We could be Martians. Life could have begun on Mars and been transferred to Earth.
Yeah.
We just don't know. But there are some predictions you can make. And one of them is that if we ever find life on another body in the solar system, there's a good possibility that it will share a heritage with us. So that brings us, after a lot of jaunty waffle, to this story about Venus. And it's bringing together that other story, which is the potential detection of this gas called phosphine in Venus, which was quite controversial. I know the lead scientist quite well who did that work, and I felt very sad for her, some of the abuse and vitriol that were directed to their team over the results.
Yeah.
But it was a really interesting detection right at the edge of sensitivity for their instruments. And what they said was that we found this gas called phosphine. On the Earth, the only way that is produced is through the action of life or through human industry. There's no other chemical process on Earth we know of that can make this. That doesn't mean that there aren't other possibilities. It's just we don't know of them. So there is a possibility that this could be being produced by life, but it's not a detection of life. And there was a whole cavalcade of arguments and stories that followed on from that. But inspired by that, the team that have done this paper have looked at it to say, if there is life in the clouds of Venus, in this temperate layer where the conditions are more similar to those on Earth than you would have on Venus's surface, could that life actually be Earth life? Could it be contamination from the Earth with bacteria that have been transferred there through this panspermia route? And they've done some calculations. There is a certain degree of speculation to try and figure out how much material is being ejected from the Earth over time, how much of it reaches Venus, and to try and put that into a sense of how many discrete bacteria would reach Venus in a billion-year period. And they've got this hand-wavy number of the billion bacteria in a billion years. Now, that's showing you how big deep time is more than anything else. And what they say is that doesn't mean there's one bacterium per year reaching Venus. It'll be clumpy. You'll get a rock delivering tens of thousands at a time. But the idea is that if you've got that level of delivery going on, all it takes is a very small number of them to be viable for life to suddenly become present there. Now, you've then got all the additional challenges of how does it get into the atmosphere, all the rest of it. But this is just an interesting thing pointing out, again, that once you bring panspermia into the picture, you can no longer say that when we found life elsewhere in the solar system, that means we've shown that life originated there. Also, as a total side point, it makes the efforts we go to in sterilizing our spacecraft seem less relevant. Because, for example, when we send spacecraft to Jupiter, to the icy moons, I can understand why we sterilize them, this planetary protection thing. But material from Earth carrying bacteria has been bombarding those moons for billions of years. If Earth life is going to get there, it's already there. So there's a lot of interesting spins from this. But it's interesting that an idea that, again, when I was young, was viewed as being really stupid and, extreme and only talked about by cranks, is now sufficiently mainstream that this kind of research is going on to investigate the what-ifs and to try and drive on from that to make predictions. The ultimate extent of this is if we find life on Mars, if we find life on Venus, and we're able to isolate a sample of it and study it, the prediction from this is that we'd find that it shares a common heritage with us, shares a common universal ancestor, I guess.
Fascinating, yeah. And what do you, like, Fred and I have often discussed this. Do you think that day will come where we might find something and we'll be able to test whether or not it has a shared origin?
I'm absolutely an optimist, and I think if there is life to be found in the solar system, we will find it. It's just a question of when rather than if. That is the big question, is if there is life there. We've got places to look. Obviously, with every decade that goes, our focus shifts a bit because we learn more. So, for example, if we'd been having this chat a decade ago, we'd have been talking about Mars, we'd have been talking about the equator of Mars and following what the wonderful rover missions are doing there. And then there was that astonishing discovery of liquid water in Mars' South Polar Cap that an Australian astronomer, Professor Graziella Caparelli, was very involved with the Italian team that did the radar studies. And suddenly, it's harder to get to Mars' South Pole, but suddenly that looks a really promising place to go, because on Earth, if you drill down into Antarctica, you find these lakes of liquid water that have been separated from the rest of the Earth for ridiculous periods of time, and they're still teeming with life. Yeah. If Mars ever had life, maybe it's still there in the waters at the South Pole. So our focus shifts a little bit. We've also got the icy moons of Jupiter and Saturn. And the more we look, the more we realize there's a lot of places we could look for life. And I'd love to think that 10 years, 20 years down the line, in a future Space Nuts episode, we'll be talking about the fact that we've definitely got some, and people are playing with it in a petri dish to learn more about it.
Yeah, and then it escapes and kills humans all over the planet. Yeah.
Oh, but they kill it with shampoo, right? That was the way the movie worked.
That's right. Yes, because I know the one you're talking about.
That was David
Duchovny. Yeah,
David Duchovny. Yeah, it was a silly film, but such good.
Evolution, I think it was called. Yeah, that's a great film. Very funny. If you'd like to read up on panspermia and the new paper that's been released, it is available online. You can also read the pre-seed version of it at space.com. Before we go, Jonty, just quickly, where are we up to with Comet 2024 G3 Atlas? Is it still alive?
It is still alive-ish, which I appreciate is a wonderful non-answer. I got some lovely photos of this comet back on Sunday evening, which I'm really pleased with, really happy with. I went out last night and there was one cloud in the sky and it was right in front of the comet. It was always the way it goes. So I'm going to keep trying the next few nights. It's still relatively easily visible with the naked eye from Southern Hemisphere locations, but the photos of it, people are turning up from around the globe now, are looking interesting. So there is a suggestion that the snowball at the heart of the comet, the nucleus, actually fell apart and fragmented about a week ago as we record this, so the 14th, 15th of January. Right. Released a copious amount of dust. And because of the nature of how comets work, that means that the comet hasn't really started to fade yet. It's enhanced the comet's tail, possibly even making it a bit more spectacular for us now, but will probably hasten the demise of the comet. And when we were talking about this previously, talked about how if you managed to live for another 600,000 years, you'd see the comet return. That's looking less likely now. I think it's pretty much done and dusted, probably. But we don't know for sure, and we'll find out more over the coming week. But in the meantime, get out there, take photos, because it's a spectacular object. It is reasonably easily visible with the naked eye if you know where to look. Yeah. Setting currently about an hour and a quarter, hour and 20 minutes after sunset. For those of us in the Southern Hemisphere, Northern Hemisphere, not so good. You can't really see it. But on photographs, digital cameras are making a spectacular job of showing this, and there's some gorgeous images out there.
Yeah, I've just looked at one on skyandtelescope.org, and yeah, you can see how the tail has become much more vivid and spread out as a consequence of its impending demise, I suppose.
There's an astonishing image on Astronomy Picture of the Day, the wonderful NASA site, for today, the 20th of January, as we're recording this, showing the comet as it was going around the sun through the LASCO camera that somebody's put together using different filters from the LASCO camera. So you've got different colored tails, and there's 1, 2, 3, 4, 5, 6, 7 different tails on the comet, which is just...
Oh, yeah, I can see that now. I just got it up.
Yeah. Wow. So that was when it was only visible in the daylight sky. Yeah. But it shows you just how active this thing got because it was so close to the sun. And there are some discussions that because it was so incredibly close in, a couple of those cells are actually probably sodium and iron. How close it got that those kind of minerals, those kind of materials were getting erupted from the surface to form tails, not just water, ice, and a little bit of gas.
Yeah, fascinating. I tried to have a look yesterday, but I think I was a bit too early, but I will make an effort. And the other thing that people are getting excited about, although you're suggesting this is a bit premature, is the upcoming planetary alignment.
Yeah, which is not something that is anywhere near as rare as the media is making it out to be. But the idea here is the planets are aligning. So your first thought is, oh, that's great. If I got my binoculars, I could see them all in the same field of view. And what it actually is that they're all in the same 180-degree arc of the sky. So if you were out a little bit after sunset, you could see all the naked eye planets, and if you got your binoculars and a telescope out, you could see Uranus and Neptune as well, all at the same time. What the coverage has left out is that Mercury is actually not joining the party at the minute. So this is viewed as being the evening sky after sunset. The first thing you'll see is Venus, Saturn's right next to it, Jupiter's high to the north for us in the southern hemisphere, to the south for those in the northern hemisphere. Mars is rising over to the east, it's just past opposition. They're all there. Uranus and Neptune are over roughly in the same part of the sky as Saturn and Venus, so you can find them with binoculars and a telescope. But Mercury is currently visible in the morning sky. For Mercury to join the party, we've got to wait another month, and that's going to be at the end of February. So maybe if Comet Atlas, which is sat low to the horizon, is masquerading as Mercury for the purposes of the current discussion, I guess, giving us a number of things to see. But if you really want to see all of them at once, you're going to have to wait till a month's time. And at that point, Saturn and Mercury and Venus will be a fair bit lower to the horizon, a little bit harder to spot, but then you will be able to see all the naked eye planets all at once in the sky at the same time. And then you'll go, well, they're spread out over 180 degrees. Isn't that pretty?
Yeah, I definitely want to have a look at that. I've got plenty of time to do it. So,
absolutely.
Yeah, fantastic. All right. Thank you, Jonty, as always. Don't forget, if you would like to follow up on those stories, you can do that in our show notes. Don't forget to visit us online at spacenutspodcast.com or spacenuts.io and check out our various pages, including our shop, which is full of all sorts of junk stuff, really good stuff that you can take a peek at. Thanks, Jonty, as always. We'll catch you on the very next episode.
Pleasure. Thanks for having me.
Jonty Horner, Professor of Astrophysics, standing in for Professor Fred Watson. And thanks to Hugh in the studio, who didn't turn up today because he actually got a free ticket on a spacecraft called SHIP. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.